Okay, this is the AQA Science Physics Unit 1 past paper from June 2013. Okay, we're going to work our way through this, 9 questions in total. You will need a calculator, you will need a ruler. The equation sheet, I'll just show you that very quickly, which we may refer to at some point. So you get given this in the exam, so you can see there, if you're stuck for any of the formulae, you can just look these up at any point, so that's good. Use black ink. Question 9 is going to be the 6-mark question, which should be answered in continuous prose, and that's the tricky one. We're going to be marked on our use of good English, organised information, and use of specialist vocabulary. And as it says there, show your workings out clearly when you do any calculations. Into question 1. The pie chart shows the proportions of electricity generated in the UK from different energy sources. So from gas, 43% of electricity is generated, 34% from coal, 16% from nuclear, 7% from renewable. Okay, question 1A1. Calculate the percentage of electricity generated by fossil fuels. So which are the fossil fuels? So that's going to be coal, that's going to be gas. So all I need to do is add up those two figures. That's going to be 34, apologies for covering that up with my little squiggle, plus 43. So that's going to give us an answer of 77%. A part 2, the pie chart shows that 7% of electricity was generated using renewable energy sources. Which of the following is not a renewable energy source? So hopefully you'll agree that solar and wind are renewable, and that oil is the one that you should tick there. Okay. Complete the following sentence for 1 part B. In some types of power station, fossil fuels are burned to heat something to produce steam. Well, what produces steam? Water. 1 part C. Burning fossil fuels releases carbon dioxide into the atmosphere. Why do many scientists think that adding carbon dioxide to the atmosphere is harmful to the environment? Tick 1 box. Remember, if you tick more than one, you will not get this mark, even if one of them is correct. Carbon dioxide is the main cause of acid rain. Carbon dioxide causes global warming. Carbon dioxide causes visual pollution. Okay, it's going to be this one for the final mark there on question 1. Okay, question 2, we have a diagram showing 4 of the 7 types of wave in the electromagnetic spectrum. So we got JKL for the ones not labelled, visible light, infrared, microwaves and radio waves. 2 part A. The 4 types of electromagnetic wave named in diagram above are used for communication. Okay, so we got a traffic signal, a satellite in space, coming off the planet there with a signal. Okay, 2A part 1. What type of electromagnetic wave is used when a traffic signal communicates with a car driver? Okay, so clearly I'm just going to see that, aren't I? So that's going to be my visible light. So I'm going to write in there visible light. A2. Which type of electromagnetic wave is used to communicate with a satellite in space? Well, that's going to be microwaves. Okay. 2 part B, gamma rays are part of the electromagnetic spectrum. Which letter, J, K or L, shows the position of gamma rays in the electromagnetic spectrum? Draw a ring around the correct answer. Okay, so have a quick look back there. So gamma rays, we're way over to the left there, and the answer is going to be J. Whoops, I'm going to circle that there. Part C, diagram 2 shows an infrared wave. So we've got A indicating the height of the wave there, we've got B from peak to peak, and we've got C there labelling from trough to peak. Which one of the arrows labelled A, B or C shows the wavelength of the wave? Write the correct answer, A, B or C. Okay, so the wavelength is either peak to peak or trough to trough. So the only letter which is indicating that is going to be B. 2C part 2. Draw a ring around the correct answer to complete the sentence. The wavelength of infrared waves is shorter than the same as or longer than the wavelength of radio waves. Hopefully from your revision, from your studies, you'd be able to say that they are shorter than the wavelength of radio waves. Question 2D. Mobile phone networks send signals using microwaves. Some people think the energy a person's head absorbs when using a mobile phone may be harmful to them. D part 1. Scientists have compared the health of people who use mobile phones with the health of people who do not use mobile phones. Which one of the following statements gives a reason why they would do this? So they're either trying to find out if a mobile phone is harmful to health, if mobile phones give out radiation, or to find out why some people are healthy. Okay, remember you need to tick one box, and hopefully you'd see that it's this one, to find out if there's any harm being done by using these phones. 2D part 2, the table gives the specific absorption rate, SAR, value for two different mobile phones. The SAR value is a measure of the maximum energy a person's head absorbs when a mobile phone is used. So phone X, phone Y, and it's 0.28 versus 1.35. A parent buys mobile phone X for her daughter. Using the information in the table, suggest why mobile phone X was the best choice. Using the information, I would say straight away that X has a lower SAR value than Y. So there's one mark for stating that, and just translating that into words, I guess. That means if mobile phones are harmful, that it's less likely to cause any harm. Or you could put the energy absorbed by the head is less. Okay, but the two we got there would be good enough for that. Question 3. A person can see an image of himself in a tall plane mirror. Okay, so we've got the top of the hat labelled A, the point where it actually meets the mirror and reflects back is called B, and then the focal point beyond is called C. The diagram shows how the person can see his hat. Which point A, B or C shows the position of the image of his hat? Write the correct answer, A, B or C, and hopefully you can see that the image is going to be part C over there. Okay. On the diagram, use a ruler to draw a light ray to show how the person can see his shoe. Okay, so what I'm going to do is follow what they did with the hat. So they go from the hat to a focal point to the eye. So I'm going to do the same thing from the shoe. Obviously I'm cheating a little bit because I've got a computer which can make these lines nice and straight. I'm going to find the point sort of halfway between, because the angle going in will be the same as the angle going out. So I'll go there, and then from that point that's going to go up to this gentleman's eye. That's perfect, but on the mark scheme there'll be a range, and as long as this point there is between sort of there and there, then you would get the mark, as long as it's showing it in that direction. Okay. Add to mine, just make it really obvious that it's going this way. Okay, so you get one mark for it coming from the shoe and out, so going in that direction. You get one mark if the angle in is the same as the angle out, as judged by the eye. I mean, they're not expecting you to measure that precisely there, but it does say if you don't use a ruler you would not get that mark. Okay, and then your third mark would be for that coming up to the going up to the gentleman's eye there, as I said. Okay. Okay. 3 part C. Which one of the words in the box is used to describe the image formed by a plane mirror? Draw a ring around the correct answer. Is it imaginary, is it real, or is it virtual? And it is indeed virtual. 4. A student investigated how the number of blades in a wind turbine affects the output voltage of the turbine. Okay. The student used the apparatus shown in the diagram. So we've got a fan, a wind turbine, we've got a clamp stand, there's a ruler to judge the distance or measure the distance, and there's a voltmeter to to make our measurements there. Okay, the fan was used to turn the wind turbine. 4a part 1, I'll just leave that diagram so you can see it there. The fan was always the same distance from the wind turbine. Why? First thing I'll say is don't just dive in and put what everybody seems to do and just dive in and write fair test. Okay, that's not enough, that's not good enough. Okay, we need some detail there. So what we need to say is that we only change one independent variable. Because if we change the number of blades and we change the distance, then that won't be a fair test. We're right in saying that, but we've got to put that detail in there, okay? 2, after switching the fan on, the student waited 20 seconds before taking the voltmeter reading. Suggest why they did that. And the answer there is we're going to wait for the fan to reach a steady speed and therefore a steady reading or measurement on the voltmeter. Okay. 4a part 3, the student changed the number of blades in the wind turbine. The student's results are shown in the scatter graph. So there's the output voltage in volts, range from 0 to 1.2. There's the number of blades. What conclusion can be made from the results in the scatter graph? So initially we've got as you increase the number of blades, the output voltage also increases. So I will start with that for my first mark. So as the number of blades increases, so does the output voltage. Okay, but that's clearly not the full story, because when we get to whoops, if I just draw this up there, when we get to this point, instead of continuing on like we might expect, we can see it's definitely plateauing off there. Okay, so we need to say something about that for our second mark. Might be as simply as saying as little change with 4, 5 or 6 blades. And it's not asterisk there, but you could also put the data in. So you could say with 3 blades we had a value of 0.9, but with 4 blades it was 1. Then after this, smaller increments. You could actually put the data in there as well. B, the amount of electricity generated using wind turbines is increasing. Which graph, A, B or C, is most likely to show the electrical power output from a wind turbine over one day? So there's the time from midnight to midnight. So is the power output going to stay the same? Is the power output going to be flat out, non-existent, same, non-existent, same, non-existent? Or is it going to be varying throughout the day as the wind changes? Okay, and hopefully you're looking at that and you're going to put C is the answer, because it's clear that the wind is just going to be very variable throughout the day. So second mark is asking you to explain that, and all you need to say there is that wind is not constant, or that the wind strength will vary throughout the day for your second mark. Okay. Question 5, a lorry has an air horn. The air horn produces sound waves in the air. Use one word to complete the following sentence. Sound waves cause air particles to something. I think I'd opt for the word there, vibrate. or you could also put oscillate. A part 2, the air horn produces sound waves at a constant frequency of 420 Hz. The wavelength of the sound wave is 0.8 of a meter. Calculate the speed of the sound wave. Okay, so this is where we could dig out that equation sheet if we weren't sure of it. Okay, and if you look at the sheet, then it'll give you the formula that the speed equals frequency times lambda, which is the wavelength. Okay, so all we need to do is 420 multiplied by 0.80, and you're going to come up with the answer there of 336, and I would just write that in there for completeness. Okay. 5 part B. A person standing at the side of the road as a lorry goes past hears the sound from the air horn change pitch. What determines the pitch of a sound? Draw a ring around the correct answer. And I'm sure you've had the oscilloscope out in your school and you've gone through this and know that to make it a higher pitch you increase the frequency of the waves, and if you want a lower pitch you lower the frequency. Okay. 5b part 2. As the lorry moves away from the person, the air horn continues to produce sound with a wavelength of 0.8. What is the wavelength of the sound waves the person heard? Draw a ring around the correct answer. And hopefully as it moves away you can see that they're actually going to get longer than 0.8. The sound waves the person heard from the moving air horn are different to the sound waves the air horn produced. What is the name given to this effect? And draw a ring on the correct answer. So they call this the Doppler Effect, and I'm sure you've heard this not just in school but in real life as an ambulance or a police car drives past at a rate of knots and you can hear that sound change. Okay, we call that the Doppler Effect. Question 6. A student used the apparatus drawn below to investigate the heating effect of an electric heater. So there we've got the heater, there we've got a thermometer inside a metal block with a power supply. Before starting the experiment, the student drew graph A. Graph A shows how the student expected the temperature of the metal block to change after the heater was switched on. So this is what they were expecting. Okay, so there's the increase in temperature and there's the time in seconds, 100, 200, 300. Okay, so describe the pattern shown in graph A, and there are 2 marks for this. Looking for here is quite simply that temperature increases and time switched on are directly proportional. You need to get across the idea that whatever increase in time we've had, you've had a similar or an equivalent increase in the temperature. So if this goes up by that amount, this goes up by that amount, and that does not change. So directly proportional is what we're looking for there. If you simply said that temperature increases over time, you'd only get a single mark there. Okay, so it's that directly proportional idea that they're looking for. A2. The student measured the room temperature. He then switched the heater on and measured the temperature of the metal block every 50 seconds. The student calculated the increase in temperature of the metal block and plotted graph B. So this is the increase over time, graph B this is. After 300 seconds, graph B shows the increase in temperature of the metal block is lower than the increase in temperature expected from graph A. Suggest one reason why. And clearly it's because some energy is going to be lost from the block to its surrounded. Lost to its surroundings. You could also say that the block wasn't insulated. A part 3. The power of the electric heater is 50 watts. Calculate the energy transferred to the heater from the electricity supply in 300 seconds. Use the correct equation once again from that physics equation sheet. And looking that up, it's going to be 300 multiplied by 50. So again, I put my workings in there, and that's going to be 15,000 joules. So I'll put that in there just to make sure we're covering that. 6b, the student uses the same heater to heat blocks of different metals each time the heater is switched on for 300 seconds. Each block of metal has the same mass but a different specific heat capacity. So there's aluminium, iron and lead. You can see the very different values there. Which one of the metals will heat up the most? Draw a ring around the correct answer. And the answer is going to be lead, with a value of 130 joules per kilogram. Give in terms of the amount of energy needed to heat the metal blocks a reason for your answer. So 2 marks, well, 1 mark for saying lead, 1 mark now for. And what you need to be saying is that lead requires least energy, or the least energy, to raise its temperature by 1 degree, which is the definition of a specific heat capacity. 6 part C, a homeowner uses an electric immersion heater to heat the water in his hot water tank. The hot water tank has no insulation. So you've got cold water coming in, there's the electrical heater, the immersion heater in there, it's made of copper, and there's the hot water that would come out. Okay? So the question, draw a ring around the correct answer to complete each sentence. Energy is transferred through the water by convection. Energy is transferred through the copper wall of the hot water tank by conduction. Okay, these are just definitions, you just need to just learn and remember them, okay? C part 2, to keep the water in the tank hot for longer, the homeowner fits an insulating jacket around the tank. The insulating jacket costs £12 to buy. The homeowner expects to save £16 each year from reduced energy bills. Calculate the payback time for the insulating jacket. So what they're saying is, how long would it take for the homeowner to be living in that house with that immersion heater to make it worthwhile buying that insulating jacket? The calculation we'd have to do here would be 12 divided by 16. If you do that as a calculation, that will come out as 0.75 years, or 3/4 of a year. Okay, I think I put 0.75. Okay. 7. The Sankey diagrams show the energy transfers in a traditional coal burning power station and a combined heat and power station. So again, I'm already thinking we're going to need our ruler here to, we can just count the little squares to actually work out the values there before I even look at the question. Okay, 7 part A, what effect does the waste energy from a power station have on the surroundings? So this waste energy there, all there, what effect does that have on its surroundings? And the answer is quite simply, it's going to warm it up. Okay, that lost energy will just warm things up. 7 part B, calculate the efficiency of the combined heat and power station. Use the correct equation for the physics equation sheet. Again, so if you weren't sure how to calculate efficiency, that's where you'd look at the sheet and just check that out before you move any further on, okay? Calculation is going to be, what useful energy do I get out of this as a percentage of the input energy that I put in? So the input energy is easy, so we got 5, 10, 15, 20. Okay, so that's the input energy that actually goes in. Okay, what useful energy do I get out? That's going to be 5, 6, 7 plus 5, 6, 7, 8, 9. So that's going to be 16. So there's the sum that I've got to do. So 16 divided by 20 is going to equal 0.8, which is 80%. It's 80% efficient. C, why is a combined heat and power station more efficient than a traditional coal burning power station? So what's the reason for its increased efficiency? There's going to be less waste energy for a start. Okay, and the waste energy is actually used to heat homes in the surrounding area. Is used to heat homes and businesses close to the power station. 7D. A combined heat and power station is usually used to meet the demand for electricity within the local area. The electricity is not transmitted and distributed through the national grid. What is the national grid? So again, only tick one box. If you tick more than one, you're going to lose the marks even if you're right with one of them. Okay, is it a system of cables and pylons, a system of cables and transformers, or a system of cables, transformers and power stations? And the actual national grid is going to be that middle one there, a system of cables and transformers. Okay. D part 2, using the electricity locally and not transmit through the national grid increases the overall efficiency of a combined heat and power station by 7%. Give one reason why. And it's quite simply, there's going to be less wasted energy in the shorter cables for only transporting that or transferring that energy a very short distance. We're not going to lose a lot of it. 8. The picture shows a person taking a hot shower. So there's a mirror labelled there. So I guess that's going to be in the question. When a person uses the shower, the mirror gets misty. Why is this? This is a 3-mark question. Okay, so need to make sure we're hitting the points there. So I would start by saying that the water evaporates in the shower. Water evaporates. The water particles go into the air. Okay, the mirror is cooler than air in this instance. Okay, water molecules that hit that mirror, water particles, use the same term, hitting the mirror, the mirror lose energy and causing condensation on the mirror. Okay. Part B. The homeowner installs an electrically heated mirror into the shower room. When a person has a shower, the heated mirror does not become misty but stays clear. Why does the mirror stay clear? Marks, I need to say that the mirror is warm, the surface is warm, the mirror is warm, therefore the rate of condensation is reduced. You'd also accept if you simply said no condensation would happen. Okay, this brings us on to the final question, and this is the QWC question. You will be assessed on using good English, organising information clearly, and using specialist terms where appropriate. So, what have we got? The diagram shows the structure of a vacuum flask. We've got a plastic cap, a double-walled glass container. There's a vacuum, a silvered surface, two of them there, and there's our hot liquid. A vacuum flask is designed to reduce the rate of energy transfer by heating processes. Describe how the design of a vacuum flask keeps the liquid inside hot. Okay, so again, just looking at these command words, okay, all we're looking to do is describe some of the key things that I'm going to be talking about. The vacuum, I'm going to mention the double wall container, we're going to mention these silvered surfaces at some point, and we're going to talk about some of the possible ways that heat can be transferred from A to B. Okay, so bearing in mind we're just trying to, how does this help keep that liquid inside hot? Okay, so this flask has lots of features that I'm going to try and mention. We'll talk about the plastic cap, and it is worth, by the way, just sketching out a little bit of a plan before you dive in. We'll talk about the fact that we've got this glass container, the plastic cap, the glass container. We will also mention the presence of the vacuum, because that's going to be important in terms of keeping that heat in. And we're also going to mention the fact that we've got these silvered surfaces. Okay, so I'm going to take each of these in turn and just explain why they add to the ability of this design to keep that heat in. Okay, and I'll just go through each of those in turn. So there's my opening sentence. The vacuum flask has 4 features which help keep the liquid inside hot, and we'll take each of these features in turn. So my first point, my first feature, the plastic cap is a poor conductor or an insulator, and this feature stops convection currents forming at the top of the flask, so stopping energy transfer by convection. The cap will also prevent particles evaporating from the hot liquid into the air. Okay, so if this wasn't an insulator, it would be cooler at the top, and we'd start getting these convection currents going on, which would start transferring heat, and if we were losing heat to the cap, then that would be one way of doing it. If any of these particles could get out, if the plastic cap wasn't a tight seal, then they would also take heat away from the liquid and cool it down. About the glass is the fact that glass once again is a poor conductor or an insulator, and using this material stops energy transfer by conduction. Okay, so that glass there, just using that stops it from conducting that heat out. The feature of a vacuum stops energy transfer by conduction or convection, as these processes require the presence of particles in order for them to pass on their energy. Okay, so I'll just add that. Feature, I've mentioned the silver surfaces, and the fact that they reduce or even stop energy transfer by radiation, as they will reflect infrared radiation back into the liquid. Okay, so that's a long answer there, but I think we've covered all of the features that we'd need to. Just a little point, don't ever be tempted to go off the line into these margins. Okay, these papers are cut down these lines pretty much and scanned into a computer. Likewise, don't write underneath here. Okay, you can go on to the next page, there's a little bit of space there, or there are continuation sheets that you can use to actually write further in. Okay, so don't do that, because when they get scanned into the computer, your answer or part of your answer could be lost, and the person doing the online marking won't be able to see your answer. Question 9b. Arctic foxes live in a very cold environment. Arctic foxes have small ears. How does the size of the ears help to keep the fox warm in a cold environment? 2 marks for this. So my answer, the ears have a small surface area. Okay, and it's very important to use that term. Simply saying the ears are small would not get you the mark. Okay, so you've got to say they have a small surface area, and this means that the energy radiated from the fox is reduced. Okay, don't say that heat loss stops. It doesn't stop heat loss, but it does reduce the rate that it is lost. So that's the end of the paper. Hopefully you've stuck with me and gone through that, and it will hopefully put you in good stead for the real exam comes along. I will be putting some more papers up as we get closer and closer, and hopefully the way that I do this will start getting a bit smoother as well and a bit quicker. Okay, thank you very much.